All right, so we're in section 13.2 today, working through chapter 13. We're going to talk about distributions. And something we call frequency tables. All right, so I'll put what we call a frequency table. I'll draw it up here, and then we'll talk about what the different parts mean. So let's say we have a meeting of athletes at school. So participants in sports, people who play sports. And we're just going to make a table of how many people participate in a particular sport. So in one column I'm going to say sport, and in another column I'm going to say the frequency, or how many people. And we call it frequency because we're just counting how often that particular sport comes up. So we call this the frequency. So we'll talk about 4 different sports. Soccer, and we say in this particular group of people that play sports, 29 people play soccer. And cross country, we have 18 people who participate in cross country. Football, we have 35. And finally, lacrosse, we have 22. I know there are other sports that people participate in, but for this example, this is all we're going to look at. So what we just drew here is called a frequency table. It's just a table that lists some category, something, and in the other column, it tells how often that thing shows up. So that's why that's what we call it the frequency. Frequency means how often. So this is a frequency table. Something that most of us have probably seen something like this before in one way or the other. But this, we're giving it a specific name today. We can find the probability, and we're talking about experimental probability today, because we're counting things. We're not using logic or mathematical reasoning. We're counting, so we're doing an experiment. We can find the probability of a person in this group playing a particular sport. So how would we figure out how many total people we're talking about here? What would we do? Zach. How would we figure out what's the total number of people that we're talking about here? Yeah. That's all we do. So we just add all of this column. So we call that the total frequency. So you'll see these words in your homework. You might see them on a quiz or a test. So the total frequency that just means how many added all together. So the total frequency here is 29 plus 18. plus 35 plus 22. Plug those in, 104. So in this particular group of athletes, there are a total of 104 people. So we call that the total frequency. Total frequency just means add all the whatever things are we're talking about. And then we're going to talk about one other thing here, the relative frequency. The relative frequency just means the probability of one thing. And we'll call it a category, one category, the probability of one category. So when we put our numbers in a table like this is called a frequency table. The total frequency is just adding all the numbers together. The relative frequency is the probability of one category. So to find the relative frequency, we just divide, we use our probability. The favorable is whatever the category is, and the total is the total frequency. So this equals the number in the category divided by the total. That's all we have to do. So this just tells us it's really already laid out here for us. This is our favorable. If we're looking for the soccer players, this is our favorable number, and this is always our total number. If we're looking for cross country, favorable, total, favorable, total. So that we just have to pick our numbers out and make our probability. So let's calculate a relative frequency. I'm going to switch pages here. So the relative frequency and again, relative frequency just means the probability of that one category. We want to find the relative frequency of the lacrosse players. So we have this meeting, we have these athletes, or this group of athletes. We want to find what's the probability if we pick one out of the group, they would be a lacrosse player, the relative frequency. So how many lacrosse players do we have? 22. And our total, we figured out, was 104. So the number in the category divided by the total, and we plug that in our calculator, and I get about 0.21, or about 21%. So in this group of athletes, the probability that any particular player plays lacrosse is about 21%. So we could say about 21% of athletes play lacrosse. So when we're talking about a frequency table, we've just put our information in a table like this. The number for the category, the total frequency is the total number in all the categories added together. The relative frequency is a probability, the probability of any one category. And to calculate our probability, we just take our number and divide it by our total. Find our total by adding them together. So questions on the frequency table. Frequency tables are nice because they kind of lay our information out for us. Well, we can use frequency tables to find what we call a probability distribution. So distribution, we're trying to figure out how the probability is kind of spread out over our information. And all we have to do for a probability distribution, sounds complicated. All we do for a probability distribution is take our frequency table and calculate the probability of each category. We're going to find the probability of soccer, probability of cross country, probability of football, probability of lacrosse. But probability distribution is just telling us find the probability of each category that's in our table. That's all we're doing. So it's a list of the probability of each category. Now, if you have a really big frequency table, probability distribution is really big, but to calculate it is really not difficult. And I want to kind of re-emphasize that we're talking about experimental probability because we're counting things. We're getting people together, we're counting them. All right, so let's look at another example of a frequency table, and this time we'll calculate a probability distribution. All right, so we're looking at a community college. And we're interested in the age of the people that attend this community college. So the age of the new students. So we're going to start out with a list. So say we get this information. We have 26 under 18 years. We have 395 between 18 and 22. $253 between 23 and 27. $139 between 28 and 32. And finally 187 over 32. And the problem asks us to write a probability distribution. So we want to know the probability of the age of each particular age at the community college for a new student. So the problem asks us, what is the probability distribution for this data for these new students at this community college? Let's start by organizing our information into a table. So let's make a frequency table. And I'm going to have my category for, one category for age, and another category for how many. So less than 18. We had how many less than 18? 26. Between 18 and 22, 395. Between 23 and 27 is 253. Already looks a little neater already now. Between 28 and 32, we have 139, and over 32 is 187. So there's our frequency table. So now we want to find our probability distribution is just the probability for each category. We want to calculate the probability for less than 18, 18 to 22, etc., etc. So we need a couple of things. We need for our relative or for our probability distribution, we need our total frequency. How did we say we found our total frequency, Jason? Adding all the numbers together. So the total frequency, we just add all our numbers. Nice and easy. So I'm going to add all of these. So total frequency equals 26 plus 395 plus 253 plus 139 plus 187. And when I plug that in my calculator, I get a nice easy number, 1,000. So we looked at 1,000 new students. Nice how that problem worked out that way. And now to calculate our probability distribution, I just calculate the probability for each category. So let's, why don't we just write that over here? So we'll calculate the probability of each one. And I'm just going to write it in red over here on the side. So the probability of less than 18 is just, I'm going to put a P up here for probability, 26 over 1,000. The probability of 18 to 22, I just take this number divided by the total. 395 over 1,000. For this one, 253 divided by 1,000, 139 divided by 1,000, and 187 divided by 1,000. And I'm just going to turn all of these into decimals. So this is about 0.026. Just plug it in my calculator. 0.395. 0.253. 0.139. Calculating all these out. And 0.187. And if you get a number, remember our probability is always a number between 0 and 1. So if we got something bigger than 1, we'd know we'd made a mistake. If we turn this number into a percent, how do we turn numbers, decimals into percents? Move the decimal 2 places to the right. Perfect. Very nice. So this would be 2.6%. I'll write that in blue down below. 2.6%. So this one would be what as a percent? 39.5%. This one would be I would, for these, for probabilities, I would leave at least one number after the decimal, because there's something special that's going to happen. 25.3, this would be 13.9%, very nice. And finally, 18.7. Perfect. So this list of probabilities is the probability distribution. Now, what do you think is going to happen when we add all of these probabilities together? So we've looked at all the incoming students. One person got it already. We looked at all the incoming students. So we're looking at the probability that they're a specific age. If we add the probabilities of each different category together, what has to happen? Has to be 100%. So if you have a probability distribution, all the probabilities have to add to 100%. So that's a way to check your work. Or if we left them as decimals, it would add to 1. And 1, if we move the decimal place over 2 places, turns into 100. So all the probabilities in a probability distribution have to add to 100%. Or 1 if you're using decimals or fractions. So that's all there is to frequency tables and probability distributions. It's just all of our numbers are laid out in tables, and we find probabilities using those numbers that we have. Any questions? So just a couple of pointers where people get confused on frequency tables is not actually doing the probabilities, but just on the vocabulary. So let's just go back really quickly and just kind of review what we talked about. A frequency table, all it means is we're listing the number of something in a category. We're just making it in a list. So that's all a frequency table is. The total frequency, your key there is the word total. Total frequency means add all these numbers together. They're how many things we're looking at all together. The relative frequency is a probability. Relative frequency is a probability of one thing in my table. So one thing that we're interested in. And we find that by how many are in that category divided by the total. Just like we did yesterday with our calculating probabilities for other things. And then the probability distribution just means find the probability of each category. Using that number, dividing it by the total. So usually when people have trouble with this is with what are the words telling me to do. And a way to check your work is in a probability distribution, your probabilities have to add to 100%. Unless there's some category that you left out. But usually if you're looking at an entire category of something, they add up to 100%. All right, are we all good?